Here's the track for the Newton's second law lab, and we're going to be using that cart right there. Now, a lot of it depends on being able to get an angle, so we're going to use the angle indicator. And the way that we can attach it, we could just stick it up here on the track, and every time we reset, we do a new angle like that. But that gets sort of be a nuisance. So what I'm going to do instead is I'm going to attach it to the track, because that nut right there on the back fits right inside the groove here. It's designed for that. So I'm going to get that set up. I've loosened it, and then it's just going to slide right into that groove. And yeah, you should be able to see that it fits right in there. I'm going to slide it right down and then tighten it up. And then I'm going to make sure there's a little bit of wiggle room here, and so I want to just by feel. All right. And so that gives you the angle. You don't need to record that angle right there, but that's just, we have a way of setting the angle. We need a couple other setups here. We need to get a motion sensor. We happen to have a motion sensor right here, what a coincidence, and the LabQuest 2 into which it hooks. And so I will get that set up. We have that setting up. Can't quite hear the clicks yet coming from the motion sensor because, well, it hasn't booted up yet. I'm going to need to get a rubber band. I'm going to need to somehow affix this to the slide over there or to the track. I have the motion sensor set up here, and I want to make sure that's parallel to it. In other words, I want to make sure that that is picking up the cart here all the way at the bottom. And so I'm going to basically start the cart up here. I can't be within about 17 or 18 centimeters. So that puts it somewhere around there. Okay, it should be good at this point. All right, it seems to be picking up the cart the entire way as I move the cart down. So I need to find the mass of the cart. And so first make sure that I grab a balance, triple beam balance here, and everything is, all the counterweights are off to the left, and get that lined up. So now we put the cart on it. I have to put it upside down, otherwise it would roll off. And I know roughly what the mass is. So it looks like a little bit more than that. We're not going to do much better than that. All right, so the back one is on 0, the middle one's on 500, and you can see where that one is. All right, so that's the mass of the cart. Now we need to get the mass of the long load mass. That is the long load mass. It is, only order of magnitude of the size of the car. And the mass is 400 something. I think it's somewhere around 490. And that's probably going to do it there. So back one is on 90, middle one's on 400, and then you can see where that one is. All right, so that's the mass of the long load mass. And now we're going to put, for procedure A, we put the long load mass into the cart, and that was a mistake I made earlier. So I'm going to stop this until I get the next part set up. We want the angle for the first part to be somewhere around 8 degrees. It doesn't have to be anywhere near exact, but that gives you an idea of the angle right there. It's, not quite 8. Looks like it's closer to 9, but eventually that'll stop shaking. And while that's settling down, so we have the track here. We're going to run the cart with a loaded long load mass in it. At the bottom, I've got 10 kilograms sitting right here, which hopefully has enough friction down here so the cart won't slip at all. And this is a cushion for the cart. Let's set up for the first trial. All right, so we're getting ready for the first trial here of part A. So first, let's zero the sensor here as best we can. And now we'll take our cart with the load mass on it. All right, so there's the angle. It's somewhere around 8 degrees. And you get a sort of a sense of the angle you can estimate. I have found that if I can center what I'm looking at, there's less parallax. All right, so I guess if I do it slowly, you pick the point when it, pause the video when that thing is in the center. All right, so now I'm going to take the cart and figure out how much force is required in order to keep it from going down. So I have the force sensor set up downstream. It's going to measure is the amount of force required to keep the cart from going down the ramp. So therefore, the net force of the cart when I take this away should be the positive value that you're about to see. And so now I want to stabilize this. All right. So you should have a decent estimate of the force there. It's obviously flipping back and forth between two. You can sort of get an estimate. You can estimate the digit by how long it spins on each. Oop, it slipped just then. There we go. All right, and now let's run the trial. Well, that was a, oh, okay. All right, so as we're looking at it, the top one is the force sensor. I probably kicked it at that moment, and so that's why you get a spike right there. We really don't care about that graph at all. So I want to show the second graph, and we want to do a curve fit when it's obviously going down. So here I'm holding it still, I let go, and that's when it hits the barrier at the end. So somewhere in between, and we can probably get a somewhat decent estimate by just zooming in on that part right there. I don't want to get too close to the end and at either end, so curve fit, position, quadratic, and there you go. If you'll notice, you've got the square brackets there, and that's the part that's actually being curve fit. But it still matches even past that, so that just feels like a good run. Let's make sure I'm doing 50 samples a second. Still doing 50 samples a second. All right, good. All right, let's go through that again. So, angle. And pause when it's in the center. Let's see if I can keep it focused. All right. And again, highlight the section where it is clearly going down the ramp. And there you go. Also feels like a good run. Coefficients are close, not quite the same, but that's why we're doing multiple trials. And again, apologies that there are no propagation of error on this lab. All right, third one. All right, so there's the angle. Right. To reduce parallax, you want somewhere where it's in the middle of the screen. So sort of pause it when it's in the middle. All right, and now we zero the force sensor. All right, so force sensor is zeroed, as much as this thing does. Let's analyze, curve fit, position, quadratic. And there we go. I feel like that was 3 good runs. All right, so we did 3 at that one. Set up for the next part. Now we need to increase the angle to about 16 degrees. At some point, this is going to start sliding, and so we'll get rubber bands for that. So trial 1 at 16-ish degrees. There's the angle. All right, so I'm zeroing the meter. And the angle. The run. And so there's the trial. Highlight, analyze, curve fit, position, quadratic. And there we go. First trial. Let's do it again. So I increase the amount of mass that I have sitting at the end, which means that there's a greater weight, which is causing a greater normal force, which causes a greater friction. So I should have double the amount of friction. All right, so we have angle. Force sensor best zeroed when on the angle. So zeroing the force sensor, putting the cart on it, and there's the force. Let's actually graph. All right. All right, angle should be about the same as it has been. Zero the force sensor. Force sensor zeroed. Stabilize the force sensor. And there it is for the third trial at the 16-degree angle. Let's crank it up another 8-ish degrees. Probably need rubber bands at this point. So, trial 1. Get that focused. Trial 1. You get an idea of the angle. We have the force sensor at an angle right there so that we can zero it. So force sensor zeroed. And, again, as best as this thing zeroes. Now figure out how much force is required. Sorry. Again, trying to keep my hands not moving. All right, hopefully that gives you enough of an idea. Now let's run the trial. That's when it fell off the track, but we don't care about that. Analyze, curve fit, position, quadratic, and there we go. You can pause it. So we'll make sure 50 samples a second, so we're good there. So angle. Zero, the force sensor is at an angle. Zero it. Put the cart on the track. Stabilize the force sensor. All right, there you go. That's trial 2 at that 20-something angle, 20-something degree angle. Trial 3, we have the angle. Zero. Thing definitely fell off. So then we highlight the part where it's actually moving down. Curve fit, position, quadratic. All right, so that is trial 3. So now let's go up another 8-ish degrees. Angle. So somewhere in the middle. All right, so angle, then put the force sensor at an angle, zero it. The force to keep the cart from going down the track. Oh, I ran the trial. So ran the trial and analyze, curve fit. And there's your coefficient. Trial 2 at this about the same angle. Zero the force sensor. All right, so that's the trial. I zoomed in already, so let's highlight good part of it. Curve fit, position, quadratic, and there we go. I think that's trial 2. Let's do it again. Trial 3, the angle. So it should be somewhere around there. That should be somewhere in the middle of the screen. Yep. Zero the force sensor. next trial. Analyze per fit position. Quadratic. All right, up to the next angle. It should be somewhere around 40 degrees, but I'm sticking with this angle because it puts the top grooves into the mortar, into the groove in the mortar, which makes it a little bit more stable. So somewhere around there, you should be able to get the correct angle. Force sensor at an angle. Zero the force sensor. All right, so the force required to keep the cart from going down the ramp. So that's what it looks like, and highlight part where it's clearly going down the ramp. And there's your coefficient. Let's do it again. Sorry, just adjusted my hand. So there's the trial. If you notice that there's a kink right there, which indicates that I had it closer than the 17 point whatever centimeters. Zoom in. Perfect position. Quadratic. There we go. Let's do it again. All right, so zero the force sensor. So zero the force sensor already. That's the force to keep the cart from going down the track. And now let's run a trial. Ran the trial. Let's highlight the part where it's clearly not fallen off the track yet. So zoom in. All right. Highlight portion that is clearly going down the track. Position. Quadratic fit. And there you are for the coefficient. I'm assuming that is enough trials for that. So now what we're going to do is sort of work backwards. We're going to start with the force, and then we need to adjust. So we start with just the plain cart. Just the plain cart. And how much force is required to keep it from falling. We're going to add mass to it and then lower the angle to try to match that force and run 4 trials. We're going to be using short masses here. So we have 2 short masses. Short mass number 1 has a 1 written on it, and also what someone measured earlier. We're going to ignore that. Give us some idea about what approximately it's going to be, but that probably was before the tape was put on. And then the second one is labeled B here, so that'll be short mass number 2. Just to give you an idea of contrast, the long mass that we just used, there's the long mass, about twice as big. All right. So it's balanced. So now we're going to put short mass number 1 on. And it should be somewhere around 250. And 250 is too much. All right, so the back one is on 40, middle one's on 200, and this one, and you can judge that, especially if I stop shaking the camera. All right, so load mass 2. That's probably what I'm going to get there. All right, so you see the back one, middle one, and then all right, so those are the masses. So back over here. So we're going to start with nothing on the cart, and we go through the exercise again. We need a cushion there. Put the force sensor up at the tilt. And 0 the force sensor. And now put the cart at the angle. And so and that gives you an idea of the force. And all right, so 3.38, 3.41, that's my target, primarily 3.38, so that's going to be my target force. All right, let's run 4 trials. And the angle, let's not forget the angle. Ran the trial. Zoom in as usual, or as sometimes usual, semi-usual, unusual. All right. And we're just going to run 4 more of those. I'm not going to measure the force every single time. So this is trial 2 here. Oh. Yeah, that is, something went wrong there. Oh, that's because I forgot to highlight. There we go. Let's do it again. Graph, zoom in, analyze, curve fit. Analyze, curve fit, position, quadratic. There we go. Still fitting. All right. So now I'm going to take load mass 1, put that on the cart, and figure out at what angle this needs to be in order to get the 3.38 newtons. So with one person, this is just going to be absolutely spectacularly fun. All right, so I have the force sensor right there. I'm going to 0 it. And now I'm going to put the cart on it with the small short load mass. I want to make sure that gets lined up. And now I need to We are at 3.81. This is not quite, we're not quite there yet, but to give you an idea of the angle temporarily. So we have to go down farther. All right, so we went a little bit too far. We're going to adjust that slightly, so 3.35. Oh, so close. Somewhere in between those two. All right, so let's adjust it slightly. For the record, I am zeroing it after each time I adjust it. And I think the request is to be within 0.05. That definitely is, and that is one of the ones that flip back and forth between. I'm going to call that good enough. So there's the angle. Let's run 4 trials. So there's the trial. Analyze curve fit position. All right, so there is the trial. Let's run it 3 more times. 2. There you go, it's trial number 2. Highlight the portion that contains what we want. Highlight while it's going down. Position. Trial number 3. Cancel meter screen. Zero the force sensor. And again, 3.38 is our target. Now, obviously, I have the long load mass on it, and so obviously it's a much greater force, and so we need to lower the angle. So 3.38 is our target. All right, so that's what we have at the new angle here. So obviously it's still too high, so let's drop it down again. Still too high, so let's do it again. So we are really darn close, so I'm just going to adjust it just a smidge. All right, so we hit our target, and it's flipping back and forth between the same 2 numbers, so we are good to go. And so let us take a gander at the angle. So this is the angle with the long load mass on it. That is the angle. So let's run 4 trials. I have the cushion down at the bottom. Put the cart on here. And we're going to just run it. If you notice that, so it's curving up, and at some point it starts to curve the other way. Somewhere around there is when it actually hits the cushion at the bottom. So I need to make sure I'm not touching that part. And we'll do one more. All right. So analyze curve fit position then. All right. So let's add a mass. So I'm going to take load mass 1 and add it to the cart, and then we'll need to readjust the angle. So take that off, put that on, 0 it. All right, so I have it there, I've zeroed it, I've adjusted the angle, we'll see how close we get to 3.38. And we need to go down just a little bit more. So close. We could get away with that according to the instructions, but let's see if we can do just a little bit better. It's now floating back and forth between 3.8 and 3.5. Let's adjust it one more time. 15 minutes. That made it worse. All right, so I'm making small adjustments here. I'm going to have to stop at that one because I'm really not going to do much better. Go too far one way, too far the other way. All right, the angle's going to be, I mean, we're talking fractions of a degree difference here. So let's try to center that. Somewhere that string is going to be in the middle of the screen. All right. Let's run 4 trials. Actually, I just realized an issue that I had. So we actually are on a spot on there. We're better than we thought. I had it slightly out of the grooves. Let's take a look at the angle one more time. Running 4 trials. So it's cruising down during this path. Analyze curve fit position. Quadratic. All right, trial 1, there we go. Do it again. All right, trial 2. Trial 3. Another one. This should be 4. Let's add the other load mass on there. Time to add second load mass. And again, 3.38 is our target. So our angle needs to drop down just a little bit. Dropped it down too much, so let's bring it back up. Too far. And that's going to have to do it. So let's check out the angle. Let's run 4 trials. There you go. And there we go. And that's all the data right there.